Okay, so moving on to the next topic. This one is very simple lecture in many ways, but very interesting nonetheless. It's called continuous integration. It's one of the main lectures we do um, in relation to projects, like managing projects. We already did one on NPM, so this is kind of like the second one on that. And really, what motivates talking about this today is that when we want to scale multi-user software projects, and what that means is, if you're working on a piece of code with you and your friend, Charlie, how do you go and take that, and how do you get 3 more people and 10 more people and 20 more people working on it, and how do companies with 1,000 people working on the same code manage that without it all just kind of breaking and exploding? And the answer is that they have automated ways to integrate and test their code. So essentially, they use computers to help make sure that people aren't breaking things. We already talked a little bit about testing last week, so you kind of start to get what this is about. But it's not just about, this isn't about writing tests. This is about the automated ways to use the running of tests to help make sure that as people merge things in, and you should be familiar with that as you merge code into master, that things don't break. So we're going to be talking about continuous integration, pipelines, runners, and doing a little bit of demonstration, which should be fun as well. So firstly, continuous integration. Continuous integration is the practice of automating the integration of code changes from multiple contributors into a single software project. That's really what we've said. It's what we mean. How do you get lots of merge requests come together and automate them coming together? And when we say automate, it's really more like helping make merges into master more frequent and more stable whilst being more frequent. You might have noticed this potentially in your first iteration, where someone might have merged something in that they shouldn't have, and it might have been like done. If only, how do you make sure that they don't do that? So typically, the way this works in practice is that continuous integration just means that there are a series of operations that are executed on the code that's part of a commit you push to the repository. So what that means is that, let's say you push some JavaScript code up to GitLab, whether it's on a branch or in master. How do you have GitLab automatically test your code, run tests you've written for your code? Or if you are writing something like C, how do you have it automatically try to compile it with GCC to see if it does compile and make sure that it doesn't not compile, right? And in a more concrete way, for within JavaScript, all continuous integration lets us do right now is to automatically run test, as in jest, allow us to automatically run jest on every commit, and to give us a visual okay or not okay summary of this on GitLab as to whether it's working or not. So let's have a look at how this happens. Let's go and get ourselves set up with a simple GitLab repository. Now, you don't ever need to create one because you've already got ones as part of all of your projects, right? I'm going to go and make a new one. You can all view this later during or after the lecture. I'm going to call this CI test like this. I'll make it internal so that you can all see it. It's just this URL, not this one. It's just this one up here, right? And then I'll go and clone that, and let's just work on it together briefly. Right, so I'll just clone this here. Done. I'll go inside of it. I'll open it up in my editor of choice. Great. Now let's go and do a few things we know we need to do, which again you don't have to do because we set up projects, but let's do it anyway. I'm going to npm init, so I'm going to make a little npm repository. Okay, so I've got my package.json here, and then I also know that from the previous lecture with testing that I need to create a couple of test files. So let's make a source folder. I'm just doing some recapping here whilst we're on this topic, just to continually reiterate, concepts. And inside the source folder, I will make a file, and that file might be called hello.js, and I might make a function in that file. That function might be called say hello name, and all it's going to do is simply return hello name, like that. And then I'm going to export say hello. So we learned about exporting from exporting, importing, and that's my little file here. And then I might want to make another one called hello.test.js, which if you remember, we essentially have, and you can go and copy this, like you don't have to go and ever write this syntax yourself. I usually would just go and copy it from other examples in the course. But we can make ourselves a simple test that says testing hello Hayden, and all this is going to have inside of it is some code that runs that says expect that calling say hello on Hayden to be hello Hayden exclamation mark, because that's what it should be. Now we can't just call say hello because we actually have to import it, right? We have to import say hello from hello like this. Now that's a quick recap of the last 2 weeks in a lot of ways, right? Really, really simple. Now again, something I have to do, which you don't have to do because we set it up for you, is I do need to again copy this random file in here. You will see we actually pasted this file into your iteration 1 repository, which again you aren't required to do because we do it for you. I know I keep saying that, but you'd be amazed how many people still ask. And then I have to install that. So the last 15 seconds you can kind of gloss over. Maybe more like 30 as we wait for this to be finished. Because I'm using Jest, I need to install Jest, so I npm install save dev Jest. I use the save dev because I'm using it for just testing, which is all locally. It's not for like the finished code. And that will go and install Jest, and then I should be able to run it. Should be pretty manageable. Great. So now when I go npm run Jest, remember run lets you run a particular library. We talked about this before by, I could normally run node modules bin Jest, and then I could run it on my hello.test file. And that should run my Jest, and it should pass. Okay, so that passed. Or alternatively, I can say npm run Jest, and npm run will look up a particular like program to, oopsie, sorry. No, I still have to add it to the package.json here. Bit complicated, but it's like when you run npm run Jest, it looks up the script Jest, which says to run Jest, and it looks for that Jest program in the node modules folder. A little bit weird, I know. So now I've got this, and it should work, and when I git status, I can see all this stuff here. Now, one thing that you have to be careful of if you're ever making your own projects, but you don't have to in this course, is again that node modules folder. You don't want that being committed. So I will go and make a .gitignore, and I will add node modules to it, and that means that it won't commit that to the repo. Now in this case, I know I want to add everything, so I'm going to use a command that I don't encourage much during the course, which is git add -- all. When you git add -- all, it takes everything, both untracked files and files that have been changed that are yet to be staged for commit, and it goes and adds them all here. Now the reason I don't recommend you do that is because eventually you will miss something and you will commit something you shouldn't. I usually tell students the story of someone I worked with in RoboCup who really loved using this command, and someone else in the team who hated them using this command, and no matter what we said, they're always likely to be totally fine. And then one day, just before a big match of robots playing soccer, right? Robots kicking balls at each other and stuff. This person committed some code to master, and they didn't notice that they'd committed a whole bunch of things they shouldn't have. Sometimes when you're developing, you might go and like change some other files, like do some debugging, and you'll end up kind of breaking something without realizing. So it's actually really good when you are committing to be very intentional about what you commit, to actually do git add here. And of course, you could git added and then check it, but it's kind of like just good practice to try and add files. I don't want to say like add every file individually, because again, if you're doing work in big projects, sometimes you will edit 12 or 13 files at a time, but it's more just be very careful here. So I'm going to go and commit that initial commit with basic tests, and then I'm going to go and push that. And I'm going to push it up here. Now, new GitLab repos have replaced master with main, but it means the same thing. You'll never see that in your repo, so you can just ignore that here. And there's all my files, right? So all my files are there together. Pretty straightforward. So yeah, I can test that. Now, the bigger question here though is how do I get GitLab to help automatically do that? And this is where we come back to our slides here. Every Git website, GitHub, Bitbucket, GitLab, have different ways of handling continuous integration. Remember, continuous integration is just a way to get the Git product to run things for you that help make sure your code works. And GitLab's is by adding a .gitlab CI file to the root of your repository. So they're basically saying that if I go to my repository here and I add a file called gitlab.ci.yaml, everything in this file GitLab will be looking at as instructions for essentially how to do continuous integration. Now, I've just gone and copied this from the slides. We'll talk about what this means in a second. But if I go and add that file, using that command again, which I shouldn't, and then I commit saying setting up CI, then I get push. It should just push to main. What'll happen is if I go back to GitLab now, you'll actually see that on this page there's this little symbol that's popped up here next to the commit hash, which says pipeline pending. Now, the reason that this little bubble has popped up all of a sudden is because GitLab has detected that I have added this file. And when I have this file in the repo, GitLab will look at it, and GitLab will go, okay, I'm going to go and run some instructions in there. And those instructions are commands, and those commands run. And whilst those commands are running, it comes up with this little pause symbol. And once the commands are done, I have to refresh the page. It either comes up with a tick or a cross. And you'll see if I click on that tick will come up here, and it'll say that, okay, there was essentially a commit, and that commit wanted to run this stuff. And then when I click on this, it gives me a whole bunch of information. Let's talk a little bit about what this is and how it works. One important thing to notice though is that these two lines here, $ echo hello, hello, that actually comes from this file here. What I said to do as part of this continuous integration was to simply output hello by echoing hello. So this here is kind of terminal commands. These are terminal commands right here. And I can make it do whatever I want. For instance, I could make it, instead of saying hello, I could say, what are you doing? Like this. And then I could commit that. Git add.gitlab CI file. Changing echo text in GitLab CI. Push that up. And we'll see again that GitLab, if I come back to my repo, the blue means, sorry. So there are a few different symbols, which we'll talk about quickly. On GitLab, these will be very different in different products. See if GitLab has them on their website. I've never looked for these before, but I was hoping they would. Just like a simple key summary of it. Maybe not. That's okay. There are mostly three different. Oh, that'll do. There are mostly three. Bugger off. There are a few different ones that you'll see a lot. The first one you saw before, which was the yellow one with the pause symbol on it. What that means is that GitLab is waiting to run your code. We'll talk more about what that means soon. The blue one with the kind of moon looking thing on it is saying that it's running your code. It's in the middle of processing it. Red means it's failed, and green means it's passed, right? Means it's all good. Pretty straightforward color coding approach. So blue here means running. Now, if it finishes running, again, GitLab won't update it until I refresh the page. So if I refresh the page now, you see it will come out as a tick. When I click on it and I click on this little check thing down here, it'll actually show you that there was different text printed out. So you can actually get a sense pretty quickly that GitLab is running the stuff I've put inside this GitLab CI file, which I've since updated. What's really cool about this is instead of putting echo what are you doing, which is just a shell command, right? It's just a command that prints that out. I can actually put what I ran on the terminal earlier, which was, if you remember, npm run jest source hello.test.js. Now what's cool about this command is that I don't necessarily need to have the file there, because jest default behavior, if you just say to run jest, what it will do is it will go and look for all of the .test.js files in your repo and it will run them for you. So all I actually need to put here is npm run jest. And I can go and update that. And I can go and push that. And now let's have a look at what happens. So it comes up again as waiting. And now if I refresh it, now it's running. And if I keep refreshing it, as it's running, you'll eventually see that it will in a moment. It's taking its time. It's got to like spool up Jest. This one's a little slower than the last one because to install Jest takes a minute. So you'll see that now it's passed, and when I click on that and I click here, you can see that it's gone through some steps and it's gone npm run jest, it's set up jest, and then it's passed it and showed the results, and it's all great. What's cool about this is that when this is in the repo, if someone comes along and they say updated implementation to no longer pass the test, say for instance they add an extra exclamation mark here, which I'll call the commit here, you know, double excited say hello function, and I push that. Now watch what happens. I don't actually need to run my test locally, although I can. It's really easy because GitLab just does the exact same thing. But again, it's waiting, it's waiting, it's running, and we'll watch this run for about 10 seconds. And in fact, I can click on it and I can watch it run in real time, mostly real time here. It's a bit laggy, but that's okay. And you'll see that it's running here, so it's actually running. And sometimes you also have to refresh this page. And you can see there it's failed. It's actually printed out the result as if I'm on terminal and showed me that the test has failed. And when I come back up here to CI test, you can see it's got a big red cross here. So this is really, really useful to give your group some peace of mind that things are actually working. What's important to remember is that the code that's run in the pipeline here in this little continuous integration is identical to the code you can run on your terminal. There's nothing special about what GitLab runs. There's nothing about the tick or the cross on GitLab that gives you more or less confidence than what you can run on your own terminal, but it is a convenience more than anything else. It's easier than pulling master all the time and running code on master all the time. Right? That's really just the crux of it. So, yep. Let's analyze this file. There's a lot of stuff in here you don't really need to worry about, but let's talk about it regardless. This top line here, image, this is basically saying what computer are you running this continuous integration on. We'll talk more about what that means later. There's a little bit of stuff here about caching. This is for performance reasons you don't need to worry about, but this is the more interesting part. You can break your continuous integration up into a series of stages. Those stages can then have little kind of jobs that run, and that job is in a particular stage and runs a particular script. And we can go and expand this idea if we want. For instance, we could add another stage called balances for no reason, and I could make a new command called say hello, which is going to be in stage checks, and its script is going to be echo hello. And then I'll make another one here called goodbye, which is going to be in stage balances, and its script is going to be echo goodbye. And we'll talk more in upcoming lectures tomorrow about how we can expand this out. So now I've got, adding more components to GitLab CI. So now when I go and have a look at it, you'll see that it's running at the moment. Have a look at how GitLab's interpreted this. So you can see that GitLab's basically said, okay, well, you've asked me to do two stages, checks and balances. So here's the check stage and here's the balances stage. And then in each of those stages, you asked me to kind of do a few different jobs, if you will. I've got the sanity job, the say hello job, and the goodbye job. All of this is wrapped up inside what GitLab calls a pipeline. A pipeline is essentially a series of jobs that runs on every commit. And you can actually see in the jobs part here, it shows you the 3 jobs to run. It's got the goodbye, the say hello, and the sanity part. And you can see if I refresh this page that it failed sanity, and then it passed say hello, which is easy because passing say hello was just literally saying hello, and then it skipped goodbye. And the reason it skipped goodbye was because the way it's set up is that you need to pass a stage. Like if you don't pass the entirety of a stage here, it doesn't move on, right? So it's like you have to pass all the jobs in a stage, and then it moves on to the next stage, and then it moves on to the next stage. So that's kind of that's how you go about grouping these things together. So 3 jobs, few different things here. That's really the structure of it. So Ennis says, so essentially this is a way of publicly displaying your tests to your group instead of just observing them yourself. Yeah, I mean, I'd say it's an easy way for anyone in your group to run the tests on any branch at any time, automatically. So I wouldn't say so much about publicly displaying your tests, because your tests would be publicly displayed just by them being on Git. Because if your tests are on Git, then your team can look at your tests, but it's like it's a convenient way to automatically run those tests. Theo has a question, which is, should we do these tests in another branch apart from master? So by default, how GitLab is set up is that once your GitLab CI file, the kind of magic configuration file, by the way, notice that the GitLab CI file, if you didn't pay attention, it's in YAML, .yml. It's a YAML file. Right, nice, easy, readable config file. This would be much uglier if it was in JSON. But to your question about should we do these tests in another branch, once it's on master, which we push for you for iteration 1, no, we did push it for iteration 1, it's now going to be in your master. So when your team goes and branches off master, it's automatically going to be in all their branches. So from now on, it will run on every branch except for master, and that's totally fine. That's pretty normal. In fact, one of the things that we enforce, if you go and read the iteration 1 spec, is that throughout iteration 1, your master branch must always have a green tick. Your other branches don't have to. And this is really important in terms of development, where you should always make sure that if your code is ready and gets merged into master, that it's always stable, that it's always giving the tick, which essentially means passing the tests. And to Jack's question, it's kind of like auto-testing your code. Yeah, that's another way to think about it. Sarah's asked, why did it fail? It failed, Sarah, because we went and updated our code before, if you remember. We went and updated it such that we put the 2 exclamation marks there. So if I was to go and undo that, it would now pass. So if I go and update this and get rid of the git status, git add, source hello, oops, JS, git commit, removing double exclamation mark issue. So you'll see now when we run it, it will again, it'll run, it's waiting and it's waiting. So you see here, these two are waiting to run. This one is kind of pre-waiting. It's like just kind of set up, and now it's running that one. Which will take a second. This say hello one's the actual jest test, so it'll take like 10 seconds to run because it's got to spool up jest. Sanity will be like instant. It's still waiting, hasn't started running. Taking its time. There we go. Now it's running. Should pass really quick. Maybe not super quick. Quick enough. And then goodbye will run shortly after. So now goodbye is waiting. It didn't wait very long, and now it's running, and then it'll pass. And then once it's passed, you'll see the overall status of the branch goes from running here to tick passed. So tick passed here, everything has passed. Now for iteration 1, we've pushed a GitLab CI file to your repo, and it just contains jest in it. In fact, I can show you really quickly. This is what your GitLab CI looks like for iteration 1. It is just literally that. It is just npm run test. And remember that test runs, all it does is run jest, which we've also added to your code base, right? Also, just quickly, don't worry about the dependencies we've added for you. You can just leave them alone. Just add more things as or if you need them. So don't worry about that. Now, a bit more theory on this topic, because I kind of covered these things a little bit. So how does this work exactly? Well, when you commit your code and it goes up to GitLab, this is all of you and your 2 team members, however many, you're all pushing code up to one repository, which is your GitLab repo. And then another group in your class has a few people in it, and they're pushing code up to their repository, and the whole cohort is pushing their code up to their repositories. Now, a simplified model of how this works is that there is one computer for all of your GitLab repos. Imagine it like, imagine literally like a sad laptop sitting by itself somewhere in the corner of a room. Its sole purpose is just to run commands for your GitLab repos. And all it's doing is one by one taking those commands, every time a commit is pushed to any branch by any project from any team member in the course, this computer's just sucking them in and running those commands, right? It's got a big queue in front of it, and it's just taking them in and running it. And it's an actual computer that's running. It's not GitLab itself. GitLab doesn't have any built-in runner. Other commercial products like GitHub and Bitbucket, which have bigger commercial applications, they often have these like runner computers, we call them, built in to the service. So when you sign up to GitHub, you don't have to kind of bring your own computer, so to speak, to run some stuff. They'll actually give you a bit, and they'll usually give you a little bit for free. And if you use them a lot, they'll try and charge you for it. For this course, CSE gives us a computer that we use to essentially run things. So there's like it's not a real computer, it's like a virtual computer in a way, but you can think of it like a computer that's sitting inside of the computer science building at UNSW. And every time you push a commit to your repository, that computer takes in your commit, runs the stuff you've told it to, which in these cases we're just running the jest test, spits out the result and gives it back to GitLab, and that's what appears up on the screen. Now, why that's relevant is this will also help you understand why it was waiting sometimes. Because what it's actually waiting for is for that runner, for that other computer, to be ready to start processing it. So the yellow meant I'm in a queue waiting to be served. The blue means I'm now ready to be served and someone's helping me out. And then, red or green means like how it went. When you're all doing a lot of work, and when I say you, I mean the cohort, the 1531 cohort. When you're all doing a lot of work together at the same time, you're all pushing maybe the day before a deadline, maybe next Friday when iteration 1 is due, the runner will have a very big queue of people wanting to use it. And the wait times to run might be, we don't know because we've restructured things this term, but it could be anywhere from a minute to like 30 minutes, depending on just how busy it is at any given time of day on any given day. And the important thing to stress here is that whilst it's a massive convenience to have the runner there to help you make sure your branches are working, it's like a sanity check. You don't need it in terms of if the runner is taking a while to process things, or for some reason the runner is down, it's not working, the computer's crashed. This happens from time to time. All you have to do is open up your terminal and just run test or jest, however you've defined it, and that will tell you. You don't need the runner. It's a convenience. It's not a necessity. It's a convenience that makes your life a little bit easier. And that's just really important to remember. We added Jest to the pipeline. That's what we just did. We did that little demo together. One thing to point out is that, and this is more like an academic note. Normally, if you were to have a runner, you would have to run npm install as part of your script as well, right? Because the runner is kind of taking your Git repo, and it doesn't have your node modules necessarily, and it is having to kind of install the libraries. But the way that we've set up 1531 is you don't need to do that. We kind of do that for you. And we also cache some things to speed things up so that the runner kind of can move as quickly as possible. But that's just kind of an important note. Like if you ever end up in your own projects or you're playing around on GitHub or GitLab in your own time, you probably will need to do some kind of npm install on the system. It won't just have all those dependencies sitting there waiting for you. Okay, and then we're getting to the end. So, quick tangent then. I'll show you something simple. I usually like to show this because it's the easy one I have access to. When you look at, when you come across continuous integration in the wild, it's usually a bit more complicated. And I can show you a fairly simple example still, which is what, again, when it comes to my work, what continuous integration looks like. I'm just trying to make sure I'm not showing anything sensitive. Yep, this will do. So, just make the window a bit bigger. Okay. So this is an example of a continuous integration that we run at work. And there are a lot of different steps here, and a lot of them don't really matter. But I just want to, and don't read into it very specifically, but I'm just trying to show you the scope of it, where you can kind of think of, this is on Bitbucket, which is another website, and they kind of got stages here, and these are jobs. So think of these as all like jobs, and these are stages. It's just a different user interface. And you can see here that there are a few different steps, and it doesn't really matter what they do, but testing is just one of them. Some other things that happen here, I don't know why test is written twice. Some other things that happen are that there's a certain command that goes and looks for unused files. So it actually goes through the repository and sees if there are any files that exist that no one is using anywhere. Basically, you know, files that should be deleted. It also goes through and cleans up the code, applies some automatic style checking as well as some type checking. These are two topics that we will actually talk about in the next lecture. Next lectures tomorrow in detail. It does the installing, like the npm installing. It also does some random checks that the database won't break and some other things. And it kind of just, it applies different steps here. So it's like, you could imagine, and this gets bigger in larger organizations. And when you look at some big organizations that are doing really big important work, you know, maybe they have 1 million people using a website a day or 1 million people using their product. Organizations like that might take 3 hours. It could take several hours. It could take 5 minutes to run. It really depends what you're doing. Some organizations as well will have more thorough checks run on master, but smaller checks run on your own branch, for instance. A good example would be, imagine if, you know, you do a test on every branch, you run npm test, you use jest, but you only do the automated style check that we'll talk about tomorrow when people merge into master, so that your actual branch checks can be quicker. There's a lot of ways you can kind of configure and play around with these activities. So in summary, continuous integration assists us in making frequent code changes because it allows us to, and this is a comment on your iteration 1. It allows us to write tests, which you should always do first, write the implementations that go with those tests, push to GitLab and create a merge request. Make sure that you have a green tick before you merge it in, the green tick being the pipeline on GitLab, and then merge it in, and then it gives you a fast, easy, confident way to essentially work through all of your code. And this is what the continuous integration summary is kind of like. It's about you write code, you merge it in, but like before or after you merge it in, you're able to kind of build, test, check, all those different steps. These things aren't set in stone. There could be 100 things in here. And then after that, you can like release it and say it's done, it works, it's ready to go out to someone. And that's their topics we'll actually talk about a lot in about 5 or so weeks, where we talk about what happens after the merging, which should be very exciting. Mention this a bunch of times, but can't mention it too many times because, again, some groups will still disregard it. It's really important to emphasize that your master branch should always be green. There is no circumstance in this course where you will have a good reason for the code on your master branch here. I know it says main, but it should be master, to not be green. If the code you have, when merged in, would cause it to go red, it shouldn't be merged in yet. And it's really quite a simple and beautiful idea. You should write code as fast as possible. I mean any organization is trying to build things, right? Your aim is to build things quickly, but whilst doing that, you are trying to push to master as frequently as humanly possible. You cannot commit too many times. You cannot create too many merge requests. The more frequent, the better. But you're also trying to, whilst doing that as frequently as possible, keep it stable. So the smallest possible merge request that can exist that passes the pipelines is the best possible merge request. If it gets smaller such that it fails the pipelines, it's probably not good enough. And a good example is like, if you write one test, like notice how we did this. Notice how we did this before. We wrote one test and we wrote an implementation for it. Passes the pipeline. Great. Get it into master. Come back and write more tests. Don't be tempted to think, I just want to do some more work first. If it passes and it's moving forward, merge it in, keep moving. Really, 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 really simple. Great. That's kind of it, I think. There's some further reading you can read about that stuff. Otherwise, we're on the feedback bit. So please leave some feedback if you have it. It's always appreciated. And, just would always love to hear about what you think. Probably just some last comments that I would make to everyone today is just around group work again. It's always great and important to be nice to your team members. So far, it's been really exciting seeing how kind everyone's been to their groups. It's winter, it's cold, COVID's still rampant, people get sick, people are dealing with a lot, interest rates are going up. I'm sure there's some people's families who are stressed out there. So please always expect competence and enthusiasm from the people you work with, right? But at the same time, do your best to look after each other too, because check in with each other is really good. Make sure everyone's okay. Last point about this lecture is that whilst we did cover a lot today, one thing I'd like to point out is that it was all kind of theory. And by that I mean that whilst we released iteration 1 today, which had this GitLab CI file in it, you don't actually have to do anything with today's lecture. Do you know what I mean? Like, we put this in your repo, the pipeline runs, it runs the tests. You don't actually have to do anything. This is all just background so that you understand how and what it is. Just for your own understanding and peace of mind. Yeah, that's really it. So anyway, let's wrap it up there. Sounds good. Thanks again.